setting up the mic. Yeah, looking good. And we are live. It's 5:40 p.m. so early evening or late afternoon. Really depends on who you're asking. Yesterday we were implementing a camera. We were implementing a RTS camera. We get the classic WASD movement. With Q and E we can rotate around the target. Fantastic. And we were just trying to get the mouse, like the mouse scroll wheel, to move for moving the camera up and down. Okay. Problem is that this depends on the FPS we are getting, and because every time like my mouse does this thing, a wheel like event is generated. Okay, but the problem is that the wheel value that is stored in the mouse state is reset, okay, every frame. Every new frame this is set to 0, and a new event has to be triggered, okay, in order to like keep scrolling, basically, in order to keep the wheel value non-zero, basically. So that's the problem. Just checking my phone, sorry. That's the problem that we are facing, and if you check it out, right now we have 190 FPS. If I enable VSync, scrolling will be not only faster but also like reasonably smoother. Okay, why? Because like this the amount of events that are triggered, the mouse wheel events, is like sorry, like it's more, I think. I hope this is like correct, the correct way of thinking, because basically the problem is that obviously we want to make our thing like frame rate independent, so we multiply by the delta time. The problem here is that in one case, so with a very high FPS, this is very small and this is very small, okay, and then the next frame it just like gets forgotten, okay, because it's reset the wheel value, okay, this this wheel multiplier basically gets to 0. So we have like one frame with when the wheel event happens, in which we have our wheel multiplier that is, for example, +1. The delta time is very small, so we have 0.0000 something, okay, offset, cool. The other way, but the problem is that the next frame the wheel multiplier will probably be 0, Okay, why? Because I can only trigger like will events at a specific rate. Okay, I cannot scroll even faster. Okay, so the idea is that I would like to so basically the problem is that there is a very sharp there's a very so my hypothesis, these are all hypotheses, okay, but my hypothesis is that the problem is one of suppose this is time, okay, I have one, I think it's 120, but for Windows, but I have like this when I tick the mouse, okay, then another when I tick the mouse, then another with a tick the mouse, okay, and so on. In all other scenarios, the will, sorry, let's call it W for will, is 0. So basically I have something like this, but all the rest, like the time for like basically in all other scenarios I have something like this. What I would love to have is something more like this, that's decreasing, like I don't know, but it's decreasing, sorry, something like this, like it's decreasing, then you get the value, so it jumps up, then it's decreasing, sorry, it's that I don't want to make it so basically decreasing, then it stays 0. Oh, a new mouse wheel event, tac, the wheel value is that, and then it starts decreasing again, okay, and so on. So basically I want to smooth away the wheel value, okay, so I want to emulate a smooth mouse wheel movement, because as of right now the wheel, it's basically a button, okay, it mechanically, it logically works the same as a button that I have to continuously like press, release, and then press again, okay, every frame I just need to trigger something like this, which I don't really want to do. So which basically that's why things don't work the way that they are supposed to. So that's huge big disclaimer, that's just like my assumption. Okay, now I'm gonna try to fix it. How? Let's disable this. Well, we are keeping track of the mouse state, okay, this is the wheel. What I want to do is to have a virtual wheel or smooth wheel, okay. This smooth wheel is basically a smooth wheel is a visualized wheel that so when a wheel event happens, the value is set to the when the wheel rotation is set, the smooth wheel or wheel smooth. So basically virtualized, sorry, virtualized or simulated smooth wheel value, simulated smooth wheel value, okay, it to wheel when wheel is then it decreases its magnitude smoothly smoothly decreases over time until it reaches 0. Okay, that's it basically. So how do we implement it? Well, the mouse state is managed by, like all other input state and input events, by our input tracker. So the idea is that here I have the wheel. Okay, now, so this is the new frame. Okay, for the new frame, let's not number them, it's easier. So I had basically advanced the current state index. I copy the mouse into the current mouse into the current state, the previous mouse state. I copy into the current keyboard state the previous keyboard state, then I reset to 0 the current mouse state. After generating the events, then okay, so this here everything is fine. So I've copied basically the virtual thingy. So the wheel, our simulated smooth wheel from before, when I generate the events. So here in the main I get the new frame, okay, when I do the new frame, new frame, float delta time in seconds, float delta time in seconds, okay, and here in the so in our current state I take the wheel smooth and I simply set it to the delta time. So basically I take the previous oops, so I take the previous mouse state, the wheel smooth, I multiply it by a float wheel smooth damping factor so I take the previous wheel smooth value, I multiply it by our damping factor, and obviously since we don't want it to be frame rate specific, I also multiply it with the delta time in seconds, and this is basically a percentage of it's the percentage of the wheel value oops, I'm getting a call. Okay, here we go. So what do I want here? There are two possibilities. Like I can say preserve X% of the current wheel value per second. So basically take or keep 90% of the every second the value that you have is decreased by 10%. Okay, by 10% of its own. So if you have 100, a wheel value of 100 after 1 second, you have 90 after another 10 seconds. After 1 second you have 81. What? No. You have yeah. So you have 81, then sorry. I've messed up. Okay, so you have 81, then you have 72, then you have does it make sense? Like 64. It's very slow though. It's very slow in this way. Or I could like say you know what? Let's do something like let's do something like this. Functional, okay. std function. We take off. Wait. The mouse thingy. Okay, it's an int though. Let's say it's a float. Okay. So takes a float. Do I need a function? Do I need a function? I simply say now let's say let's say function float. I don't like it. can't do it. Secretly in type delphin function. Okay, yeah, that's the C way of doing it. What's the C++ way of doing it? Is it possible? I don't think it is. Std function std function. Oh, that's the syntax. Okay, that's the syntax. Cool. Can I float val float dt? So I can do it. Fantastic. And I can using I don't know how to call it though. So let's call it will smooth function. Okay, let's call it like that. Let's do so we pass a function, way better. And with our will smooth function, we do the take as an argument the previous and the delta time in seconds. Fantastic. So the new will smooth will be the previous will smooth. So our will smooth function applied to the previous will smooth and passing the new delta time. Passing the new delta time. So for example, I want to halve it every second. Does it work? So calculate start with 100 for example, and I halve it by, I don't know, yeah, I halve it, okay, after 1 second. Then I halve this, and after 1 second I got but I'll never do this. So the delta time in seconds would be, I don't know. Also the problem is that okay, so let's say, I don't care, let's float oh god, design it's hard to design, always hard. So what I do is simple, take this, multiply it by and then multiply it by the delta time in seconds, fixed. So for example, there should be a value between the smooth damp would be the percentage of the damping I want. The problem is that because I could use a fixed value, but the problem is that the fixed value could be different for different input devices, so I probably wouldn't want that to be a fixed value. So the idea is to make it a percentage of the original value, okay, a percentage of the original value, and then decrease it. Okay. But I cannot do a percentage of the original value because I don't save the original value right now. Right now the original value is like cleared. Oh god. I could go here and not only have a smooth, but have a smooth start. Smoothing over, let's say. Let's pretend it's good. So the idea here now is that this is the percentage of start to subtract, to reduce the current will smooth. So this is the percentage of will smooth start used to reduce the current. So percentage of the will smooth start value used to reduce the current, to damp the current will smooth value. Yeah, I like it. So the idea is that now with the input tracker the will is 0, the will smooth would be. So we copied the current mouse, the previous mouse state in the current mouse state, the previous mouse state in the current mouse state. We set the current mouse state to 0, so we set the current mouse state with value to 0. The current mouse state will smooth field is the current will, so basically it's the current will smooth, okay, decremented by the current mouse state will smooth start multiplied by the damping factor multiplied by the delta time in seconds. It's very long-winded thingy, which I really don't like it. But so it's basically this. So I take the then compute new will smooth value. Okay. So we basically take the current wills. Okay, so the idea is that we can write it like this. We take the current will smooth value, we decrement it by the will smooth start multiplied by the will smooth dump multiplied it by the delta time in seconds. Okay, so for example, okay, so this is the percentage of will smooth start value used to dump the percentage per seconds of, okay, yeah. Obviously, when we generate a new will event, okay, we not only push the event, but it means that, because right here in the main on will, so on mouse wheel, okay, get mouse, the wheel is delta, mouse get mouse, so here the mouse wheel is delta, but the mouse will smooth start is the new delta. And obviously the will smooth right now is the delta. So I take that this is the new value on mouse wheel. Okay. When we first obviously we first does it make sense to place this code, this virtual mouse code into like the input tracker? I don't know. For now, let's make it work. The input tracker generate a new frame. When I generate a new frame, I compute the thing, then I pump all the messages. So I will trigger also this thing right here. When triggering that thing right here, right there, when triggering that, so we do the thing and then we generate the events, which is very simple. We just generate the events. If I do this, something's broke. What's broke? Oh, we need the damping factor. Let's say 0.1f for now. Oh, obviously, something that we get the mouse get with multiplier, of course, but we should also try to get will smooth multiplier. And the idea smooth multiplier, camera vertical will multiplier okay. It's very smooth, but the problem is that it never ends. It never ends. That's the interesting part. So we got the smoothing thing, but the problem is that it never ends. It never ends. It never ends. Why? simply because I never stop. Allow me to with that's why. First and foremost, okay. So it never stops. So if because the problem is that the wheel smooth can both be positive and negative. If it's negative, I want to check whether or not it's greater than 0. If it's positive, I want to check, okay, so that is that if was greater than 0, if it's less than 0, then we just like set it to 0. If this was less than 0, if this is greater than 0, we set it to 0. Very clunky. Very clunky, but I want to have a better this is obscene. I'm loving it. Look at how smooth It is. Good lord. The smooth scrolling experience, guys. Let's try 5. Let's try 6. I like it. Another feature that we may want to add is the fact that the closer I am to like the lower the height, the smaller my like the movement of the height it is. The higher the height, the greater the movement. Okay, so basically the greater the vertical movement speed. Okay, so the lower the height, the smaller the movement, the smaller the vertical movement speed, the higher the height, the higher the vertical movement speed. So we want like something like that. Okay, for now this looks cool. Obviously this is hard-coded, we don't want it like that, but oh yeah, let's check with the VSync. Yeah, it's I think it's the same. I think it's the same, but I may be wrong. Okay, fantastic. Something that actually works. This looks like shit. So to do this looks like shit. Like the problem is that what we are doing here is actually in terms of like code organization, why the input tracker would want to know something like this. Why not just implement basically a virtual mouse, okay? But then like the input tracker is a good spot. The input tracker, I think it's a good spot. I think, at least. I don't know really. I don't really know. That this is like this is very error prone. This is very error prone. Is very error prone. Like, you should never do something like that. Should I encapsulate just the mouse? Do we need the mouse? Do we actually need the mouse? I don't know. Like the mouse, expose the raw like mouse thingy, or do we just because at this point the wheel should something that it's something that should be hidden, you know. This should be hidden. No one should be able to touch it apart from the entity that manages the mouse state. This should be like the thing that gets exposed. Obviously X, Y and the buttons. Yeah. So this should be hidden. These should be hidden. I don't know. Yeah. Smooth. So basically emulate this sort of thing, emulating the mouse basically. Having a virtual mouse on top of our mouse, okay, and then when we set the mouse, okay, but where do we pass the damping factor to the input tracker? Like the input tracker should not do the damping, the damping of the input tracker should not be doing the damping. Like it's the mouse itself that should be doing the damping. The wheel smooth damp should like be passed though to the tracker, because it's the tracker that actually manages the mouse state, so it makes sense. Okay, cool, we actually got something done. It's unexpected. The thing works. The thing works reasonably well, which I'm surprised. Like, I was doing house chores, and I came up with this sort of this idea came to mind. Okay, I was pleasantly surprised by the effectiveness of it. Like, dang. Obviously it's a linear thingy, oops, obviously, but I think it's cool. Maybe something with more, like, something more interesting. We could do something more interesting, do, for example, an exponential drop off or something like that, but honestly, as a minimum viable product, I find it like maybe it would be cool to be able to conserve momentum. So basically, the more I scroll, right now, if I'm scrolling and when I scroll again, I reset the smooth value. But what if I don't know, I want to add to it? Why not adding? Oh. Unless you are changing direction. In that case, maybe you don't want to add to it. But I mean, you may want just to snap it to the other side. Okay, like some considerations that we might want to like think about. Okay, it's 6:42. We have been live for, I don't know, I think 1 hour. And oh yeah, let's commit before logging off. So implement virtual smooth mouse scroll. Fantastic. Okay, so see you next time, hopefully soon. Bye bye.